Hi everyone, my name's Lawrence Hooker and I'm a technical consultant here at Excitech. In this short video we'll be taking a look at some of the key features of Autodesk Inventor 2016. We'll begin with a new process called AnyCAD. This gives us the ability to intelligently reference in 3D geometry from third-party MCAD tools such as SolidWorks, Pro Engineer, CATIA, Siemens NX and a few others. We'll then move into associative DWG workflows. We'll then look at a couple of new drawing enhancements that Autodesk have made. Also then we'll move into sheet metal components. One of the most prominent new features here is the support for zero bend radii. We'll then look at some of the editing tools for our freeform shape creation. And finally we'll finish up with additive manufacturing. So let's take a look at the workflow for AnyCAD. So for me, this is one of the most prominent new features for the last couple of years. Pretty much any company or supply chain you may be working in will have the ability to perhaps source data from many other different manufacturers. Now also we might be working with aerospace contractors, automotive vendors and so on, and they're unlikely to be using the same tool as us. They might be using something like PTC Creo, CATIA, NX, a whole myriad of different MCAD tools. So AnyCAD technology allows us to intelligently reference that data from the third-party MCAD tool directly into our Inventor assembly. If that component then changes, our Inventor assembly will update. Now, we've always had the ability to import data from some of these third-party MCAD tools, but it wouldn't, of course, have updated inside our Inventor session. So we now have that capability. And for the demonstration, I'll be using PTC Creo and Autodesk Inventor. Okay, so here we are in Inventor 2016. Before we actually create a new assembly, let's take a minute to have a look at the new layout within our starting screen. This is now called the Inventor home screen, and you'll see it's split into three areas. We have the ability to create basic new templates on the left-hand side here. I could switch that to advanced quite easily with the little arrow here. All these panels are resizable as well, which is quite nice. We can also flip the arrangement of those panels. On the right hand side here I have access to all of my projects, so I can make the projects active via here and also review the properties of these and actually add shortcuts into the projects. Something I really like is the ability to see the file details here of the selected component in the list here. That's quite nice, just to identify what folder path it's in, whereabouts it's actually saved within my system as well, which is quite good. We can also maximise the recent file list, and you can see here we have all these recent documents as thumbnails being shown at the moment. We have the ability to pin some of these components as well, so if I start to pin them you can see it then keeps these in the pinned area here, and very much like a little folder system you can unpin, pin, roll these up and down and also filter information as well. Okay, so let's go ahead and create a new assembly. In this example we're going to place an imported CAD file in. So let's go and pick our Creo part and open this up. Now the new function here is of course the ability to reference the model through rather than convert the model. So I'm going to use reference here. I'm going to tell Inventor only to bring the solids through, and of course we can change our units in here. So I'll just say from source. Okay, and that data is now referenced in. So here we have our Creo component. On the left hand side here you can see that if I right mouse click over the part I could edit the import, suppress the link which would stop it updating, or in fact break the link. Okay, so let's now go into Creo here, PTC Creo, and we'll make some changes. So we'll start by changing the extrusion height. Yeah, perhaps we'll just change it to there, say for example. Let's also change the width as well. So perhaps we'll reduce that to 250 there. Okay, we'll regenerate the component and save it. So back in Inventor, let's see what's happened. Well, you can see I've got a strike of lightning across my PTC Creo part. That means it needs updating. So let's click the update button, and you can now see that Inventor simply updates that and references in the newly saved component. Okay, What about if I build some Inventor geometry off of this? So what I'm going to do now is build a work plane from it. Yep, so we'll have a work plane that's constrained to those two flat faces there, and we'll go through the process again. So let's go back into my Creo component in here. Once again, we'll edit the extrusion on this. We'll regenerate the model and we'll save it. Back to Inventor here and update. And of course you can now see that the work plane is updated as well. Now of course the significance behind that is if I then choose to build new features off of that work plane, those features will move as well. So we can have a very intelligent system here where we can at will reference CAD data from other third-party MCAD solutions such as CATIA, SolidWorks, Siemens NX, ProEngineer, bring them into Inventor and then build my components off of that. Okay, so in this section we're going to take a look at the new features of the DWG workflow with AutoCAD. Okay, so we have a scenario here on the right hand side where you can see that we have a simple two-dimensional DWG file. It's just a simple hand wheel component in 2 dimensions. On the left hand side we have the Inventor IPT file. How we've done this is we've actually associatively linked that DWG file into an IPT file, and then perhaps just use commands such as revolve, hole, sweep and so on to create the component. If we go back and change that DWG file by simply perhaps stretching or moving geometry and save that, then that would invoke an update within Inventor, and then our component will dynamically update. Okay, so let's now take a look at that in the software itself. So here I am inside Inventor, and I'm going to start by creating a new parts file. In here I'll go to import, and you can see we have a DWG file here, so I'll go ahead and open this up and I'll place this onto the XY plane and just choose my origin. Okay, so you can now see the dialog here is telling us that this is going to create an associative underlay, and if I want to make use of the geometry I can project it. If we take a look at the browser here, you'll notice that we have the DWG file linked in there, and if I right mouse over it, you'll notice here I could suppress the link, I could break the link, or indeed I could control the layer visibilities if I wanted to adjust the layers. So in this case I'm going to make use of a new tool that enables me to project the data through. So you'll notice up here we have a completely new command called project DWG geometry. In this case I'm just going to project off the circles that are representing the vessels. We'll now create some work axes through here as well. So I'm just going to associate these back to the XY plane in here. Yeah, we'll go through and create those work axes. Okay. Right, so at this point we'll save the drawing away. So let's click on save. Okay, and this one's going to be called vessel layout. Okay, so now we'll generate a new assembly file and we'll place in the data that we require. Let's just come up a few levels here. So there we are, a vessel layout. Okay, we'll place the part in and I'm going to ground and root this. So at this point, let's now go ahead and place my assemblies in. Okay, so what we need for these layouts here is basically the vessel, and we'll bring this data in. Okay, we'll just drop 4 of them around there. Now what I'm going to do is constrain these to the work axes. So we'll just go around and constrain all these vessels in here. I'm not going to worry too much about the vertical placement. Just for this demonstration we're going to look at literally just a physical placement of these, yeah, in relation to the DWG file. So maybe that's the vertical height for those. Now the real key thing I want to show you here is what happens if I go back and change the DWG file. So here's the DWG opened inside AutoCAD, and what I'm going to do here is start to move the geometry. Yep. So we'll select this vessel here, perhaps we'll move that out over here, this one will move into here. So what I need to do is save. And now if we switch back to Inventor, what we should notice here is that we have the update button lit up here. And if I click on update, you can now see those vessels have changed. Now what's actually happening is this: if I actually open up the layout component here, you'll notice I've got that dynamic DWG linked in. If I go back to the AutoCAD file again, and once again move these vessels back to a slightly different location, like so, hit save, back into Inventor, you'll notice we get the strike of lightning, very much like we just saw with any CAD, and then of course I could update this here. Click on the return button and instantly that updates my assembly. So as well as driving component models with this, I see a much bigger use for this with creating assemblies. So what we'll be able to do is use a flat AutoCAD drawing as an underlay and have that linked to our physical Inventor components. Okay, let's now move into the drawing view enhancements. So we have a few new enhancements here. First thing we're going to look at is the drawing views dialog box and the dynamic way that we can now move and scale views and also orientate views to place down onto a drawing. We'll also look at some of the new symbology that we can use whilst editing a dimension or creating text within an IDW file. And lastly, we'll look at the revised ballooning tools. So let's go into the product itself. And you can see we have an assembly of a valve inside here. And we'll go directly now into creating a drawing of this. Okay, so if we now click on the base command, first thing you'll notice is that we have a frame around the view, and this has dynamic glyphs on it. So I can use this to drag the scale, and it's snapping to default scales. We can also use this to project views. So as I move my mouse over here, you can see that Inventor is going to project a view directly above that view that I've got at the moment or below. We can also use it to move the view around just by dragging. Now, the other thing you'll notice up here is that I have the ability to use the view cube whilst creating these views. So for example here, if I wanted a plane view over the top, it's nice and easy to use the view cube to get that orientation. So let's go ahead and place a couple of views out. There we have it. And what we'll do here is we'll also create hidden detail lines in here. Notice we have new icons in here, so this box has had a little bit of a makeover as well, which is good. Okay, and what we'll now do is we'll create a new base view up here, which is going to be an isometric view. Okay, so there it is, and again I can scale that quite nicely through here and place that where I want. Okay, so let's now have a look at some text improvements. So if I get an overall dimension across this, from there to there for example, as I place the dimension down, you can see that we have many more symbols that we can now make use of. We'll also now have a look at the revised ballooning routines as well. So first up, I'm going to create a parts list that we'll place down onto the drawing. And now we'll create some balloons. So if I go to the auto balloon option here, one of the things to look out for here is you'll notice that we can now use our own user-defined symbols for balloons. That's quite a nice option. Also, you'll see here that if I select this view and all the components within it, and now ask Inventor to place out some horizontal balloons, what it's going to do here is try and find the closest point on each component as a reference. In previous releases you might have found that the reference arrow here went all the way through to the back edge of the part. So that's quite nice. Okay, let's now take a look at some freeform modelling. In this section we're going to just take a small look at some of the enhancements made to the freeform shape creation. So for this example I'm going to create a new chair back and also a new chair seat. We'll see here that Autodesk have completely revamped a ribbon across the top here, and you can see that we have many more panels on there and quite a few new commands. So the best thing to do is just get in and start to show you that in action. So here we are inside Inventor, and you'll notice I have some basic components of the chair modelled. What I want to do now is just start to explore some basic ideas for a seat for the chair and also a back. So here I'm going to start with the box command. I'll pick a location where I want this to start and just place a box down. Now at this point I can just start to stretch this data around just to get a rough idea of the concept. So that's a little bit too big, so we can stretch that back a little bit there. I'm quite happy with the width of that. So let's now stretch up the height. Okay, we'll go a little bit more than that. Okay, that looks fairly good. So we can now increase perhaps the face count a little bit here. And we can also put on some symmetry. So here I'm asking for width symmetry. Right, so at this point we can now start to edit the form. So in this example, you'll notice here we have various different filters to allow me to pick points, edges and so on. So I'm going to pick an edge here. Notice I only have to pick one side because I've selected symmetry across the centre of this. And of course now we can start to pull this around. So let's have a slight depression into the seat there. And what I'm going to do is angle that depression back. So you can see as I pull the rotation around, what that's actually doing is rotating that edge there. Now, probably to be a little bit more successful than that, what I'd probably rather do is perhaps pick the pad faces themselves. Now, to do that, I'll probably want to subdivide these a little bit further. So I can go to the subdivide command. Yeah, we'll pick a face there, and also we'll subdivide this face here. Good. So now we'll select these two faces here, and again we'll go back to edit form and we'll pillow this down just as we did before. Now this time what I better do is rotate. So you can now see I can rotate that around. Yep, let's just get that looking about right there. So we're going to have a nice sort of deep seat towards the back there, which is good. Okay, now we'll make sure that we have a nice area for our sort of legs to fall through. So again, we can edit the form here. Yeah, we'll just slender that down a little bit there. And perhaps what I'll do here is I'll just extend that out just a little bit in there. Let's pull that a little bit further there. So you can see this is all very conceptual at the moment. Okay, now what I'm going to do is, again, just edit this edge back a little bit here. And we'll take both of those edges there. And we'll push that somewhere like that. Okay, so fairly happy with that at the moment. Again, we can come back and fine tune that a bit later on. So we'll finish that form there. And again, here we can assign a material to this. So let's go through and make that chair, for example. Okay, so there's the seat for the chair itself. So let's now go and create the back of the chair as well. So again, we'll start off with the box command. We'll pick a position where we're going to start this. And once again, I can start to just pull this geometry around to get a rough concept. Okay, so that's looking okay at the moment. Again, we'll create slightly more thickness to this. And once again, I would like some symmetry. Good, so there's our area ready to start. So now what I'm going to do is just start to pull this around once again. So you can see now I've just been able to use a very simple window selection set there to pull that around. So we'll go for something like that. Here, what I might want to do is start to pull this around a little bit as well. So I'm going to have a little bit of an area where that's coming back there. Let's now come into here, pull that a little bit further like so, and then right down the bottom, let's just make sure we select the bottom faces there. We'll pull that back a little bit. Okay. Perhaps what we'll do is we'll increase the width of the chair up the top here a little bit as well. And we'll narrow it down to the bottom. Yeah, just squeeze that in a little bit. Yeah, and we'll take these edges back in, perhaps like that. and these edges can come out to give us a bit of lumbar support. Okay, so again I can add my material to that. Yep, so this again will be the chair material there. Okay, now again at this point, if I look at that, I think, well, okay, the back is probably way too big. So of course we can go back and edit this very easily. So if we just do some edit freeform on here, we can go back to being able to reduce the height of that very simply, like that. Perhaps I want to pinch in these edges a little bit there as well. So what I'm going to do in this case is use the point there, just to pull that back in. Yep. And then perhaps we'll take the whole edge this time. So we'll select those two edges there. And again, you can see I can squeeze that in. Now as we start to squeeze this, you'll notice also that we can have a soft modification in here as well. And the sort of thing we can do here, it's very easy, just play around with these slider bars to get like a much nicer blend between the components that I'm using there. Okay, so that looks quite nice. Again, I could set an accurate radius in there if I wanted to. So perhaps we'll go for a slightly smaller radius in there. Yep, and we'll come out with that modelling tool. And there's my conceptual chair. Okay. Okay, let's take a look at the sheet metal enhancements. So there's been a few sheet metal improvements in this release. One of the major ones is the ability now to use multi-bodied solids within the sheet metal workflow. So on the left hand side of the slide here, you can see that I've modelled in the same IPT file 3 separate solids representing a base, a mounting plate and a mounting panel. On the right hand side we then have the sheet metal components that have been created in this workflow. Then to finish up we can click on Make Components, and Inventor will save an IPT file out for each of the base solids and then assemble them together inside an assembly. So let's look at that within the product itself. Okay, so here we are in an IPT file. If we take a look on the left hand side of the browser here, we'll see that we have the multi-bodied solid and we have the 3 separate solids that I've created here. And if you look at the workflow, it's fairly straightforward, just solid modelling. So the first stage here is to convert this into sheet metal. So as soon as I pick this, you'll notice Inventor then invokes the sheet metal defaults command. So I can pick on any face here, and you'll notice now it actually pulls the thickness through from that particular selection. So once I've done this, I can now start to process these components into sheet metal parts. So let's start with the mounting plate here. So what I'm going to do is just turn the visibility of these components off. And we can now use traditional sheet metal tools to start to rip the corners out here. So we'll grab that corner there and rip that out, this one here. Then we can put bends in as usual. So let's start with the flange here. Now another nice change is the ability to have a 0 bend radius. So that wasn't possible in older releases. So let's do a 0 bend radius in here. Okay, and there's my first component done. So we'll now move into the next one. So let's go to perhaps the base part. Turn the visibility of this one on. Now in this case I'm probably going to need to get rid of this area here. So let's just use the split command for that. Yeah, we'll go ahead and split the solid in this example. Like so. Okay. And now once again we can start to tear out the corners, so we can use the rip feature here. Okay, and I'll just go around and rip out all these edges as well. And also the back edges here. Okay, so we can now start to get our bends in. So same process you've seen before, so we can select the components to put the bend in. Okay, I'll just do a couple more just to show you the full workflow, and then we'll create the finished assembly. Okay, so we'll get the final components inside here, like so. Right, now once we've achieved that, what we can then do is go ahead and make components from these. So we can select our solids that we require in here. This is going to be the assembly that Inventor will create. Okay, and there's my finished assembly file. Now one of the nice things now is, of course, I can open up the components here and then of course flatten these out. So let's just make sure we've got the A side defined. And then we'll flat pattern. Okay, and there's our flat pattern created. Next, we'll move into additive manufacturing. This is a fairly new area for Autodesk. We've always had the ability to output a STL file from Inventor, but we haven't been able to interact with it. For example, choosing a machine, choosing a process that we're going to use for that, and also being able to orientate the part in relation to the machine's bed. Now, additive manufacturing isn't just covering three-dimensional printing, it's also looking at other processes such as extrusion and also things like sintering as well. So let's now take a look at the process in a little bit more detail. So you can see that we have a new ribbon inside Inventor 2016. And this allows us first to choose our machine that we're going to use. What we can then do is set the orientation of the product in relation to the machine's bed. If the part is too big to print in one go, or it makes sense to break the part down into smaller pieces, we can then partition the component. And what Inventor will then give us the example to do is create things like pegs and holes to reassemble the components together after the manufacture. And then we have the option of outputting it to 3D Print Studio. So let's now take a look at this process in the product itself. So I have an IPT file open inside Inventor. First thing I'm going to do is go to the Environments ribbon, and you'll notice here that we can now go into the 3D Print environment. Now, the first display I see here is basically the envelope of our machine. Now I can see that my component will not fit inside this particular machine, so I'm going to select a new printer for this. So perhaps we'll look at the Mojo, and you can see now we have a slightly bigger bed and a slightly bigger envelope. The next thing I'm going to do is set the orientation for my component. So first we'll choose the face that I want to sit on the bed, which will be this face here. Okay, and that's done. Now I'm going to split the part as well, so I'm going to create some geometry to help me define a work plane that I'm going to use to split. And then we can use the partition command. So we'll select the work plane that we're going to use to partition this. And in this example we can now start to create our pegs. So I'm going to choose the peg diameter that I want to run with here, and also the peg depth. And now in here we can start to position out our pegs. So let's have a peg here, another one down here. Now I'm just at random picking positions that I think the pegs need to go in. But actually what you can do, you can place these a little bit more accurately if you want by editing the sketch afterwards. Okay, that's good for me so far, so we'll create those pegs. Now in this example, what we'll now be able to do is now reposition these components. So what I'm going to do here is start by picking this wall here, the side wall, and this side wall here. So I'm giving myself a 5mm envelope to the side of the machine itself, and you can see Inventor's now setting that envelope for me. Okay, I'll leave this one where it is for the minute, but you can now see that we've had our pegs and our holes modelled to allow us to reassemble this part after manufacture. Okay, so at this point I could have a look at the mesh display if I wanted to. I could also go into some print options and start to look at surface deviations, edge lengths, aspect ratios and so on. But what I'm going to do here is output it to Print Studio. Now this is a technology preview at the moment. So let's just take a look at this. So again, you can see that we have various different machine beds and things in here. What I'm going to do is just show you the preparation that we can do with this. So what this is going to do is now model up some supports for my particular component. Okay, so they're the supports modelled. Once we have the supports modelled, what we can then do is preview the prints. It just takes a few seconds for Print Studio to complete this task, and you can now see we have our layers completed. So what we can now do is start to preview the slices. So as I drag the bar up here, you can see the product is now showing me where the slices occur through here. I can also have a depth preview as well in here. And more importantly, you'll notice here that I have the estimated time of completion for manufacture, which is 5 hours 43 minutes in this case, and also the estimated material that the process is going to use. And of course the last step here is I can output this directly to the printer. Okay, so it just remains for me to thank you for watching the video. If you have any further questions, don't hesitate to call us on 0345 370 1500, or of course you can go onto our website at www.excitec.co.uk. Thank you very much.